this tutorial, I will be concluding the topic on the MFP 3D AFM. Specifically, I will show you how to image in both attractive and repulsive regime. Also, I will show you how to save and export the scan images. For this demonstration, I will be scanning a calcite surface. The surface could be challenging to scan, but I will show you some tricks to get around the challenges. First, find the critical amplitude of a tip as discussed in the last video. For this tip, it is about 280 mV. So to image in the attractive regime, I have to tune down the free amplitude to about 140 mV, about half of the critical amplitude. Also, ensure that the set point is about 80% of the free amplitude. I will adjust it to 115 mV. You can set the scan area here. For this demonstration, I'm setting it to 200 nanometers. So the tip will scan the area 200 by 200 nanometers. Then click on the Frame Up button to start imaging. You can see that the cantilever is in the attractive regime. For imaging, you need to monitor these graphs here. That is the height retrace, the amplitude retrace, phase retrace, and the Z sensor retrace monitor. Each monitor has the area map, which shows contrast, and the profile plot as well. The height monitor shows you the surface contour and profile of the sample as the tip scans across the surface. For instance, the valley in this plot corresponds to the dark pixels on the contrast map, while the crest on the plot corresponds to the white pixels on the map. There is about 3 nanometers height difference between this area here. The red and blue line in the line plot shows the trace and retrace as the tip move across scan along the surface. So as a rule of thumb, these two lines should more or less coincide. The Z sensor retrace map reflects the movement of the Z piezo in response to the amplitude of the cantilever. The amplitude retrace map shows the change in amplitude as the tip moves across the sample surface. As a reminder, we mentioned in earlier episodes that we are imaging in amplitude modulation mode. This means that the amplitude map should show no contrast as the tip scans the surface area. This is because ideally, the Z piezo should adjust its height to keep the amplitude constant to the set point amplitude. If you noticed contrast in the amplitude retrace map, you might have to re-prepare your sample or repeat the calibration processes. Lastly is the phase retrace map. This map is used to monitor the chemistry on a sample surface. Surface with the same chemistry will show no contrast, while the presence of contrast in the map shows different chemistry, hence different materials. Let us get back to the imaging process. When I click the Frame Up button, I noticed the trace and retrace lines did not coincide. So I reduced the integral gain located in the menu panel. I keep playing with this value until the lines appear to coincide more or less. Sometimes you might have to reduce the value of the set point a bit to get the two lines to coincide while imaging. Also, make sure that the amplitude map is uniform, that is no contrast. I would like to emphasize that the contrast noticed here on the phase map is not due to difference in surface chemistry as we discussed earlier on. I know this because it appears around the same area as the height map here. So this is due to artifacts on the sample surface. However, it would have been a different case if the map appears like this. In this case, the contrast is due to chemistry because when I compared the corresponding region in the height map, I see no contrast here in the height map. To image in the repulsive regime, increase the free amplitude about 3 times the critical amplitude. Adjust the set point as appropriate. Follow the same procedure to adjust the integral gain or set point as discussed earlier for the attractive regime if necessary. You can see that the cantilever is in the repulsive regime. Finally, to export your images, click on the AFM Analysis tab here. Then click on the Browse Save Data. Then on this folder icon here, click on the Browse tab. Find the Save Image and click on it. The GUI here saves all the map. You can change the color by clicking on the Color Map drop-down menu here and select the appropriate color. Then navigate to the File menu and save the graphics. Select your desired file format. You can change the name, then click in the Do It tab here. Then choose your file path and save. You can also click on the Analysis panel here, the Section tab, the Draw tab, and draw a line across the height map to get the profile plot. You can also get the surface roughness and the RMS value and export it. To export the 3D map, click on the 3D icon here. You can rotate the view by holding down the middle button. Then on the panel here, click on the New tab and Export Layout. Navigate to the File menu, click on the Save Graphic tab and the Save Graphic GUI. Rename the file and click on the Do It button. Your file should now be in your chosen directory or in the document folder on the systems. This concludes the lesson 1 on the MFP3D AFM. In the next video, we will be looking at the Cipher AFM from Asylum Research.